Yo, what's going on guys, Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And today we're going to continue the Radix Sort sorting algorithm topic which we started off in the previous video. So this is the part 2 of Radix Sort algorithm, and in this part 2, as the title of the video suggests, we're going to take a look at the pseudocode and we're going to implement this Radix Sort pseudocode onto our existing array. So in part 1 what we did is we took a little bit of theoretical approach. We saw what is Radix Sort, we saw the working, and we saw the step-by-step working and implemented that on the array. And I mentioned that Radix Sort uses counting sort internally. So to visualize that, we need to see and understand the pseudocode, because in part 1 we did not see the counting sort work. We saw the overall working in a diagrammatic way where the buckets were created and how visually Radix Sort would work, but how programmatically it would work is more clear when we understand this pseudocode. Okay. So if you don't know what Radix Sort is, please watch part 1. And if you don't know what counting sort is, we've talked about it also in this data structures and algorithms playlist. Please make sure you watch counting sort because that is more important, because Radix Sort definitely uses counting sort in a slightly different way and we're going to understand that as well. So yeah, this is going to be a little lengthy video, but this is going to be in-depth understanding of Radix Sort pseudocode. And ultimately in part 3, that is in next video after this one, we're going to use this pseudocode and we're going to write a program to implement the Radix Sort. So anyways, with that being said, let's get started. If you're new to my channel, my name is Tanmay Sakpal and I do a lot of computer science and information technology video tutorials like computer programming, development, technology talks, and a lot more on this channel. So if that's something you're interested into, then definitely subscribe and turn on the notifications to get the latest updates and never miss out on such important topics. Okay, so as you can see on the screen on the left hand side, we have the pseudocode, we have the Radix Sort function. So pseudocode is not exactly a proper code and it is not exactly English steps also. It's kind of a mixture of both, and there is no specific or standard guidelines to write a pseudocode. It has to be part code, part English, and you can mix it up according to you as long as it is step by step and understandable. But you can see we have created a function. We are passing our input array and the size of the array. Now step number 1 is to take the array as the input. So that's the step number 1, take the input array with the size. So this is basic. Moving on, step 2 is get max from the array. Now if you've seen part 1, we were finding out the maximum value in the input array because we want to know the number of digits that the maximum value has. So this was the very same example and we concluded that 802 is the max number, right? So this is the max number over here and it has 3 digits. So that's why we had 3 passes over there. So similarly, we're going to calculate or get the max from the array, and for this, when we go ahead and get max programmatically, we have to write a separate function over here. So you can see this is the get max. It is returning an integer which is the maximum number from the array. So we have to pass the array and the size of the array obviously, and then it will return the maximum and it will be stored in this m variable. So over here we have the get max function. What it does, let's go step by step. In step number 1, we say max is equal to ARR of 0. So we create a variable named max. We say it is ARR of 0. So applying it on this array, ARR of 0 is 170, right? So max becomes 170 for the first time. Then in step 2, we have a for loop. We say int I is equal to 1 till size. So I less than size. So what is the size of this array? 8. So we will start from 1 and we will go to 7. That is the last index position, right? So we'll start from 1 and we will go till 7 because we are not considering 0th index because that value is already stored in this max variable. Let me use another color. I'll use yellow. So in the for loop, we are just checking if ARR of I is greater than the max variable. So starting from 1, that is index position 1, we take 45. So we check 45 greater than max, and currently max has 170. Is 45 greater than 170? No. So this inner if statement will not be called. Again we will come over here, I will become 2. So now we will go over here, we'll take 75. So this 45 becomes 75. We'll check if 75 greater than 170. No. So again this inner loop will not, or inner if condition will not be executed. Again we will go on top, I will become 90. Is 90 greater than 170? No. We'll move forward. Now we have 802. Is 802 greater than 170? Yes. So now this if condition has become true, and now we will go inside this and we are saying max is equal to ARR of I. So the new max value will be 802. So this is very basic enough. If we just dry run it, we will basically just go through all the elements in the input array, and ultimately the max variable, that is this one, will have the maximum number which is returned at step 3. So this step 3 is where we are returning this max variable, and it will be now stored in the m variable over here. Okay, so this is the get max function. So after the get max function is called, m will have 802. Okay, so this is how programmatically things are going to look like. And now step 3 is where we do the counting sort. So here it is saying do counting sort for every digit. Now we've got our max value as 802. In step number 3.1, we are saying for int div is equal to 1, m divided by div greater than 0, div star equal to 10, and inside the for loop we are calling counting sort on this array. We are passing array size and this div variable. So we need to understand what is happening at step number 3, 3.1 and 3.1.1. Now if you've seen the working, that is part 1 of Radix Sort, I said that if we have 3 digits, counting sort, or the process should be repeated 3 times. If it is 4 digits, it would be 4 times. So we need to have that mechanism programmatically also, right? So some kind of algorithm or some kind of arithmetic calculation should happen such that counting sort will be called only 3 times. So this is where this for loop condition comes into picture. So let's evaluate this for loop condition. Okay, so coming inside this for loop, we are saying int div equals to 1. So initially div value is equal to 1. Then we are saying m divided by div has to be greater than 0. What is m here? We've decided that the max m over here is 802. That is the max value in the array. So now the condition is m, which is 802. So let me write it over here, 802. So m divided by div is equal to 802 divided by 1, because div has become 1 initially. That is the first time div is 1. Now this m divided by div equals to 802 by 1, which is obviously going to be 802. Now is 802 greater than 0? This is the condition. So this is the condition part. So 802 is obviously greater than 0. So we will go inside the for loop. So this is pass 1. Okay, let's not consider 3.1.1 as of now. Let's assume that we've done pass 1. So pass 1 is done. Now we again come back to the for loop. Now the increment is happening as follows. It's saying div star equal to 10. What is the star equal to? Star equal to means div is equal to div star, which is multiplication, 10. So initially obviously div was 1. Okay, so now it would be 1 is equal to 1 star 10, which is gonna be 10. So let me actually erase this and write everything properly. Initially div was 1. Now div has become 10. M is obviously gonna be 802 only, right? But this condition I hope you have understood, or this increment operation is happening in multiples of 10. So now second time div has become 10. Now again the condition will be checked, m by div. So this time div is 10. So 802 divided by 10 is equal to 80.2. But since it is an integer, m is also integer and this div is also integer, this fractional part will be truncated. Obviously it is not considered when we go ahead in programming part. So is 80 greater than 0? That's the condition. That is m by div greater than 0. Is 80 greater than 0? Yes. So we will have another pass 2, right? Again, let's not consider 3.1.1 as of now. Let's see this counting sort is called second time, and now again we are coming at the for loop. So coming back at the for loop for the third time, now div again becomes div star equal to 10. Div is already 10. So 10 star equal to 10 means 10 into 10, that is 100, and that is what is stored in div variable. So div becomes 100. So now div value is gonna be 100. Okay. Again, m value is obviously gonna be 802. So this time the condition again is gonna check m by div, which is gonna be 802 divided by 100. So this time it would be 8.02. And as I mentioned, the fractional part will be truncated. Now 8 is still greater than 0. Obviously, that is the condition. M by 2 should be greater than 0. So this is true. So we will have pass 3, right? And now let's say again the counting sort is called. We again come back at the for loop. This time div becomes 1000 because div star equal to 10 would be 100 into 10. So 100 into 10 would be 1000. So div now becomes 1000. And now when we do m by div, it would be 802 divided by 1000, which is 0.802. And since fractional part is truncated, we are left with 0. So is 0 greater than 0? No. This time 0 is not greater than 0. It is equal to 0, but it is not greater than 0. So this time the for loop condition will become false and the fourth round of counting sort will not happen. So now you can see that depending upon how many digits we have in the maximum number, that many times we are having passes. So we had 3 passes. So this is how programmatically you can control the number of passes depending upon the number of digits in the maximum number. Now this div value or this div variable plays one more role, because if you see inside the counting sort, we are passing this div. So why are we passing this div will be only understood when we take a look at this counting sort algorithm. So now let's take a look at this counting sort algorithm. Okay, so I hope you've understood how 3 times counting sort is called using this for loop and using this condition. Make a note of these values of div, especially the first 3 values, that is 1, 10 and 100. So let me write it above somewhere and then we'll go to counting sort pseudocode. So div value changes from 1, 10 and 100. And each of these values is passed in this counting sort function at every iteration in the radix sort function. So radix sort is calling counting sort internally, right? And it is called 3 times because we have maximum digits 3 in the maximum number. Now let's see this counting sort pseudocode, because that's when we understand internally what is happening and how counting sort works inside radix sort, because there is a slight difference. Now for all those who have seen the counting sort tutorial, things would be very similar except slight difference. So let's see what the difference is. Okay, so this is the pseudocode for counting sort function. And if you remember the counting sort that we've seen in the original counting sort tutorial, we were only considering array and the size of the array. And the first step was to take the input. But over here we are passing the input as arguments in this counting sort function. So that first step is missing. Apart from that, we are using this extra div variable, which is coming from the for loop, and every time in the for loop the div value changes from 1 to 10 to 100. Okay, so only 3 values are going to be passed. That's why I've written it over here. And now let's go step by step. A lot of things are going to be similar. So first thing is obviously create the output array, because in counting sort we create an auxiliary array to store the output and then transfer all the values from the output array into the original array, that is the input array. So first things first, create an output of the same size of the input array. So whatever size of the input array, we have to create an output array. So let's do that. Okay, so here we have the output array. This is also of size 8. Next step is to take the range or number of unique elements. Now in radix sort, what happens is counting sort is called on individual digits. So counting sort will be called for the units place once, for the tens place once, and for the hundreds place once. So ultimately the range of unique numbers is always gonna lie between 0 to 9, which means we only have 10 unique elements or numbers, right? So that's why the range in our case is always going to be 10, because in a decimal number system, 0 to 9 are the values that are single digit numbers. We don't go outside that range. So that's why range in our case is 10. Now why do we need this range? Because as you remember in counting sort, we have to create a count array which will be of the size range. So this is what the step 3 is. We are saying for int I equals to 0 to I less than range, and we are creating a count array. I've not mentioned we have created a count array in after step 2, but consider that we are creating a count array of the size of range and we are making all the values initially 0. So let's create that. So this is our count array of size 10, because that's our range, and range is the number of unique elements. We have 0 to 9, which means we have 10 elements. So our count array also becomes size 10. I've made one more count array. It is basically one and the same thing. That's because in next step we will take the cumulative count, just like what we did in the counting sort. So yeah, the first time, that is this first for loop in step 3, we are saying from 0 to the range. So from 0 till the range, that is from 0 to 9, we are making all the elements 0. So the count initially is gonna be 0. Okay, so now next step is we have to increment the count in the count array depending upon which digit we are considering in the input array. Now in plain counting sort, in the simple counting sort algorithm, it was an easy scenario because we were only considering digits or numbers which were single digit numbers. So our range itself was 0 to 9. But in our array, in this input array, you can see that these numbers are not single digit. These numbers are multiple digits having 2 digits or 3 digits and so on. But in Radix Sort, the concept is we are applying counting sort internally on individual digits and not the entire number, right? And another thing to remember is we will apply counting sort starting from the LSB, that is least significant bit, to the MSB. So that is from right to left. So the LSB over here is the units place. So very first time we want to apply counting sort on this individual digit of these numbers and not the entire number, right? So how do you get just this digit from this number? So this is where this div variable that we've passed in this function is going to help us get that individual digit. So in this for loop, you can see we are using this equation or this expression. Let's try to evaluate this expression, what it is. So we are saying count of, so we are accessing the count array and now we want the index position in the count array. But we have a particular equation over here. We are saying ARR of I divided by div. So first we have to calculate ARR of I. Of course we are starting from 0 to the size. What is the size of the array? 8. So we are going to go from 0 to 7 because it is I less than size. So initially ARR of 0 is going to be 170, right? So let's calculate ARR of I divided by div first, right? So because it is in brackets, you can see we have yellow brackets. Let me just show it to you. So this is the first expression which is there in the brackets. So we have to evaluate that first. What is ARR of I? As I mentioned, it is 170. What is the value of div? Now for the first time when the counting sort is called, remember Radix Sort was calling counting sort 3 times in the for loop. That's what we saw previously in the pseudocode. And for the first time, I have written the value of div which is 1. You can see 1, 10 and 100. So for the first time it is going to be 1. So 170 by 1 is obviously going to be 170. Now the next part of this expression is this operator which is modulo operator. So we are saying 170 mod 10. When you do a modulo operation, we will always get the remainder. And the remainder in this case is going to be 0 because 170 is completely divisible by 10. So this entire expression is giving us 0. So ultimately we are saying count of 0 plus plus. So this value in this count array will become 1. So we took 170, we evaluated this expression and we got this individual LSB, that is the units place, which is 0, and we went to the 0th location in the count array and we incremented it by 1. So if you remember the counting sort, this is pretty much the mechanism, right? The numbers in the input array are mapped to the indexes of the count array. However, in this case, in our Radix Sort situation where we have numbers having multiple digits, this number is not representing the index position. This individual digit is now representing the index position in the count array. So this last 0 is mapped with this 0. Similarly, this 5 is going to be mapped with the index position 5. Again, this 5 is going to be mapped with the index position 5. So let's evaluate this expression one more time for 45. So now I value becomes 1. I was initially 0, now I has become 1. Because we are going to go from 0 to 7, right? We are going to completely iterate through this input array. So we are at this place. So again, we are saying count of ARR of I divided by div mod 10. So again, ARR of I divided by div. What is ARR of I now? ARR of 1. ARR of 1 is 45. So we take 45, we divide it by 1 because initially for the first time div value is 1. That would give us 45 only. Then we say mod 10. When you do 45 mod 10, we get 5 because 45 is not completely divisible by 10. Obviously it is divisible, we get a decimal point number, but in modulo operation, as I mentioned, we only get the remainder, and this remainder is going to be 5. So ultimately it is saying count of 5 plus plus. So remember, there is a plus plus over here. So we take this number, we only take the LSB, that is the units place, for the first iteration of counting sort. We come to this 5 index position in the count array and we make it plus 1. Now similarly, we will go one element at a time in the input array. This expression will be evaluated every time. The div value initially is going to be 1 only, so it's not going to change. So we will take these elements. So let's calculate this for the third position or third element. We take 75, we evaluate this expression, we get the LSB, it is mapped to this index position in the count array, we increment it, we make it 2. Then we move forward, we take 90, we evaluate this expression, we get 0, 0 is mapped with the 0 index position in the count array, so we increment it by 1 again, so it becomes 2. Similarly, I'm just going to do it for all the other elements in the input array. I hope you've understood how this expression is working to get the particular index position. You guys can pause the video and try run it yourself step by step for every element if you want, because that will give you a little bit more practice. But at the end of this for loop, after we iterate from 0 to 7, in the count array, this is something that we have, and this is the result of this for loop. So we will have count of 0 as 2, which means the elements in the input array having zeros as the LSB are 2, that is 170 and 90. Then we have 2 elements that have the LSB of 2. So you can see 802 and single digit number 2. So that's the count we are storing over here. So we have applied counting sort on single digits, that is the LSB of these numbers. Okay. Now next step in the counting sort algorithm is obviously to take a cumulative sum of the count. This is also similar to what we've seen in the counting sort. So we're saying count of I is equal to count of I plus count of I minus 1. And we start from I equals to 1 to the range. So we'll start from 1 to 9 because range is from 0 to 9, right? So what we're doing, we're taking this number 0, that is count of I plus 1. So you can see count of I is 1. So we take this value, we are starting from 1, right? So initially count of I is going to be count of 1. So to evaluate this, it would be count of 1 is equal to count of 1 plus count of I minus 1 is count of 0. So count of 1 is 0, you can see over here, and count of 0 is 2. So 0 plus 2 is going to be stored at count of 1. So we take a sum of 2 and 0 and store the total over here itself. So the first element, that is 0th element, is going to be as it is, but then we do 2 plus 0, we store it over here, and then we do this element plus the previous element, which is now modified to 2. So 2 plus 2, we get 4. Then we do this element, that is 3 index position plus 2 index position, that is 4 plus 0, we store it over here itself. And this is happening in the same array. Okay, so these are same arrays only. I've just written it 2 times so that I can show you how the sum is happening. Then we take a sum of 4 index position and 3 index position and store it at 4 index position. So 4 plus 1 is 5. Then we do this, that is 5 plus 2 is 7. Then we do this, 7 plus 1 is 8. Then we do this, 0 plus 8 is 8, and pretty much everything is gonna be 8. Okay. So after this for loop, that is 5 and 5.1, we've got our cumulative count. So this is cumulative count, and this is done to get the exact positions of the elements in the input array for the output array. So now the mapping has to be done from the input array to the output array, right? So for that, we need this cumulative count. Okay, so now coming to one of the most crucial for loops or steps in the counting sort, wherein the mapping is done with the output array, that is this array, and the input array. So now we have to pick one element from the input array and place it in some location in the output array, and that some location will come from this cumulative count array that we've just calculated. Okay. So you can see the output array is the outermost array, and on the right hand side we have the input array. So let's evaluate this expression starting from I equals to size minus 1 to I greater than equal to 0. So here we are going in reverse order. So we are going from I equals to size minus 1. What is the size of the array? 8. 8 minus 1 is 7. So we are going to run from 7 to I equals to greater than or equal to 0. So 7 to 0. So starting from 7 to 0 from right to left. Now the reason why we go from right to left is because we want to place these individual elements in proper order. For example, if 170 has come before 90 and both of them have 0 in their LSB, in their units place, for the first time the counting sort is called. So 170 in the output array also has to come before 90. And to achieve this, we have to go in reverse order. So what you can do is you can change this order and start from 0 to 7 also to check if this condition is satisfied. If you go from 0 to 7, what will happen is 170 will be coming after 90, and that is not correct. So that's why we have to go in reverse order. And if what I'm saying is not making sense, let's actually try to go and dry run this step by step, and then you'll understand it will make more sense. Okay. So starting off with the 7th element, we are taking ARR of I, which is ARR of 7. We are going in reverse order. So ARR of I is 66. So for the RHS, we have 66. So 66 is going to be stored at some output location, which is going to be evaluated using this expression. That is count of ARR of I by div mod 10 minus 1. So let's evaluate this. So internally, we have to first calculate ARR of I by div. What is ARR of I? ARR of 7, because we started from 7, so it is 66. So 66 divided by div. Div is 1, obviously for the first time. So this is still first round of counting sort being called, right? From the Radix sort. So div values are only going to change from 1, 10 and 100. And right now we are at 1. So 66 by 1 is going to be 66 obviously. Then we have mod 10. 66 mod 10 is going to be 6. So we are saying count of 6 minus 1 is going to give us the index position of the output array. So count of 6 is what? In the cumulative count that we've counted, we come at the 6th index position, count of 6. The count stored over here is 8. We are saying 8 minus 1. So now this count becomes 7. So this becomes 7. And this is what we are interested in. So we are going to go in the output array at the 7th index position and store this RHS, that is ARR of I, that is 66. Okay. So coming in the output array at the 7th index position, which is actually the last index position, we are going to take this 66 from the input array and transfer it over here. Okay. So this is the first step, that is 6.1 inside the for loop. Now again, I will get decremented. I will become 6 because we are going from 7 to 0 in a reverse order. So now we will take this number. So let's evaluate this one more time for better understanding. So I is now 6. ARR of 6 is 2. So RHS is pretty easy. Let's evaluate LHS. ARR of I, again 2 divided by div. Div is 1. For the first time, this is div mod 10. Now 2 mod 10 is obviously gonna give us 2 only, right? So this will give us 2. So we get 2. So we are getting count of 2. But we also have this minus 1. We have to say minus 1. So what is count of 2? Count of 2 in the cumulative count over here that we just calculated is 4. So we have to say 4 minus 1, which is 3. So this change will happen over here also. This will become 3. And now this 3 is basically the output position, that is the index position in the output array, where we have to store this 2. So in the output array, we will go at position 3. We will store this number 2. Okay, so let's quickly do it for other values also. So now I will become 5, right? So let me just write the I value over here also. We just did this. We are going from 7 to 0. So now we are at 5. I is become 5. What is the value at 5? 24 in the input array. So on the right hand side, we have 24 as it is. On the left hand side, we have 24 divided by 1 mod 10. So that will give us the count position. So that would be 24 divided by 1 is 24. 24 mod 10 is 4. So count of 4 minus 1, that would be, what is count of 4? Count of 4 is 5. So 5 minus 1 will become 4, right? So 5 minus 1 will become 4, and this is the position of the output array where we have to store this 24. So output of 4 will have 24. Now I becomes 4. So what is ARR of 4? 802. So let's write that over here, 802. So the left hand side equation becomes ARR of I, which is 802 divided by 1 mod 10. Obviously this is also gonna give us 2, because 802 divided by 1 is 802, and 802 mod 10 will give us 2. So that is count of 2, and then we also have this minus 1 over here. So we have minus 1. What is count of 2? Count of 2 over here has become 3. So that will become 2, because count of 2 is 3. 3 minus 1 will become 2. And that is the position in the output array where we have to store this 802. So at output location of 2 is where we store 802. Okay. So now I value becomes 3. Let's calculate it for 3. What is the value of ARR of I? That is ARR of 3. It is 90. So I'm gonna write 90 over here. For the right hand side, for the left hand side we have 90 divided by 1 mod 10. This whole thing obviously is gonna give us 0. So count of 0, which is 2. So 2. Then we have minus 1. So it becomes 1. So I'll write 1 over here. And that is the position in the output array where we have to store 90. So I'll store 90 over here. Then I value becomes 2. ARR of 2 is ARR of this position, that is 75. So we get count of 5 minus 1. I'm directly evaluating it now. So by now you must get the calculations. What is count of 5? Count of 5 is 7. So 7 minus 1 is 6. So that new value becomes 6 at count of 5. So in the output array, at 6th location or 6th index position is where we store 75. So this is 75 coming over here. Then I becomes 1. Again count of 5, because when we take 45, so we have 45 divided by 1, which is div value, mod 10, which gives us 5. So count of 5 minus 1. So this time count of 5 is 6. So it would be 6 minus 1. 6 minus 1 is 5. So output position of 5 is where we store 45. And in the count array also it becomes 5. Right? So output of 5 is where we store 45. And lastly we come at this index position, which will obviously go in this 170. That is 0th index. So after this entire 6 and 6.1 for loop, we have applied counting sort on this array, but we have applied counting sort only on the least significant digit or least significant bit. In this case it was the units place, because it was the very first iteration where div was 1. And now if you observe, in the input array 170 was coming first before 90. Both of them have zeros in their LSB, in their units place. So in the output array 170 is obviously coming before 90. So this is why we had to go from right to left, that is from 7 to 0. Another example would be 802 and 2. So if 802 is coming before 2 in the input array, it has to come before 2 in the output array also. And if you're wondering why this is still not sorted, it is because we've still not reached the end. This is just the one iteration of counting sort, which is called 3 times. So in the Radix Sort pseudocode previously, we saw that counting sort is gonna be called 3 times, with the only change happening in the div value, which is gonna go from 1 to 10 to 100. So I just showed you one entire iteration of counting sort where div was 1. Now we have to apply counting sort on this newly found output. So if you see step 7, we still have to cover step 7. We are saying for I equals to 0 to size, output of I is now transferred into the original input array. So all these values 170, 90, 8022, 24, 45, 75, 66 are now transferred back to this original input array. So now the original input array will be like this, where you can see 170, 90, 802, 002, 024, 045, 075, 066. I've added these extra zeros because now we're going to need them, because now for the second time when the counting sort is called, the div value is now become 10, and now the least significant bit that we want to apply counting sort is going to be the tens place, because we've already applied counting sort based on the units place. So now we want to apply it to the tens place. Okay, so these are the digits on which we are going to apply counting sort for the second time. So how would the counting sort now be applied just on this digit, because I've already shown you how it applies on the units place. So let's quickly go step by step again for the second time, and this time we'll go a little fast. The only difference is going to happen is in this expression. So let me just first erase this extra markings. Okay, so for the second time now the counting sort is called, with the only difference being the div value is now equals to 10. Okay, so let me write it again over here, div equals to 10. Again, create the output array, we've created it. Take the range is obviously going to be 10. Again, for loop, the first for loop makes all the count elements 0. Initially it's going to be all zeros. The next for loop increments the count, but this time since div is 10, let's see how the mapping is done. Now as I mentioned, we want to take the digit at the tens place. So let's evaluate for the 0 position. So let's say I equals to 0. So because I is from 0 to size, so I will go from 0 to 7, because size is 8. Size of the input array is 8. Now we are going from one element to another in the input array. So we are taking the input array ARR of I. Initially I is 0. What is ARR of 0 now? It is 170. So we take 170. Then it is divided by div. But this time, as I mentioned, div is 10. So 170 divided by 10. It is in brackets. So that would give us 17. Outside this brackets, outside this, we have again a modulo operation. So 17 mod 10 will give us 7. So now you can see we take this 170 and we perform this expression on it, and we get this digit which is at the tens position, which is 7. So at that position 7, we are saying count of 7 plus plus. So count in the count array at the 7th index position, we say plus plus, we increment it by 1. So this is how you are now getting the individual digits at the tens position. That is because div has now become 10 for the second iteration. So I'm not going to repeat this over and over again. I hope you've got it. You can try run it on every element from the input array, and you will get the digit from the tens place, and then the respective count will get plus plus. I'm just going to quickly update it over here because it will become repetitive otherwise. Okay, so after this step number 4 and 4.1 happens, that is after we take the count of these individual digits. So you can see 7 has happened 2 times over here and over here. Hence at the index position in the count array, the count is 2. Then we have 9, so count is 1. For 0, we have 1 and 2 occurrences. So at index position 0, we have the count of 2. Similarly, we have all other counts at their appropriate index positions. So now this digit is mapped to its appropriate index position. Okay. Then of course at step 5 and 5.1, we take the cumulative addition. So 0 plus 2. So first element is going to be as it is. Then we have 0 plus 2, which is 2. Then we have 1 plus 2, which is 3. Then we have 0 plus 3, which is 3 again. Then we have 1 plus 3, which is 4. Again 0 plus 4 is going to be 4. 1 plus 4 is going to be 5. 5 plus 2 is going to be 7. 0 plus 7 is going to be 7. And 1 plus 7 is going to be 8. That's how this for loop will work. You can try run it. We've already done it, so I'm not going ahead. And now again the more important for loop, where we are going to take elements from the input array starting from I equals to size minus 1, which is 7, because 8 minus 1 is 7, starting from 7 to 0. So we will go from 7 to 0 again. And now we have to pick one element from here and put it in the output array in such a way that it has to be mapped in a particular position. So let's calculate that quickly. taking the first element at 7th position, let's say I equals to 7. So ARR of 7 is 066. So 066 has to be put in the output array at a particular position which is coming from this expression. So count of ARR of I. What is ARR of I? That is ARR of 7. ARR of 7 is 066. So we say 066 divided by div. Div, as I mentioned, for this iteration is 10. So 066 divided by 10 is gonna give us 6.6. Now as I mentioned, this is an integer value. So the point part, the decimal part, is gonna be truncated. That is, the fractional part is gonna be truncated. So we are gonna left out with 6. Okay. So 066 divided by 10 is gonna give you 6. So that's happening inside these brackets. After that we have a mod 10. So 6 mod 10 is obviously gonna give you 6 only because it is not directly divisible. So ultimately we are getting count of 6, and then we have a -1, so that's -1. So what is count of 6? We just calculated it as 5. So we are saying 5 minus 1. That would give us 4. And this is where the entire expression evaluates. So at the position output of 4 is where we want to store ARR of I, that is ARR of 7, that is 066. So this count also first becomes less, that is count of 6 is 5 only, na? So it becomes 4. Let me just use another color. It becomes 4. And output of 4, that is output of this position, is where we have to store this 066. So I'll enter 066 over here. Okay. So again, this expression helps us get that particular digit. So in 066, we got the 6 as a digit. Now if you move back, starting from, we are going in the backward direction from 7 to 0. So for this element, we are going to get the 7th index position in the cumulative count array. So when I becomes 6, let me just again write it over here. So when I becomes 6, the expression goes as follows. What is ARR of 6? ARR of 6 is 075, that is 75 basically. We are saying 75 divided by 10, which is 7.5, which is going to be 7. So it's going to be 7. Then we have mod 10. So ultimately we are going to get 7 only. So this is count of 7. So count of 7 is targeted, as I mentioned. What is the count over here? It is 7. So we have to do -1. So it becomes 6. So 7 minus 1 becomes 6. And at this position of the output array, because that's the outermost array, so output of 6 is where we have to put 75. So output of 6 is where we have to put 75. So similarly for 045, we will target the index position 4 in the count array. We will decrement this by 1, so it will become 3. And at the third index position is where we have to store 045. Then we will go at this, we take 024, we will target the second index position. In the count array, we will decrement it by 1, we will make it 2. And in the output array, at the 2 index position, we will store 024. Then we will go to 002, we will take, or we will get the 0 index position. In the count array, we will decrement it by 1. So it will become 1. At the 1 index position in the output array is where we will put 002. We will go to 802, we will take 0. We will come to 0 index position which has 1. We will decrement it by 1, so it becomes 0. And at the 0th index position in the output array is where we will store 802. We will come to 1 index position in the input array, we will take this 9. We will go to the 9th index position, we will decrement it by 1, it becomes 7. And at the 7th index position is where we will input this 90. And the last element goes over here, because we will access the 7th index position in the count array. The 7th index position is 6. We will decrement it by 1, it will become 5. And at the 5th index position is where we put 170. So this is 170. It will come over here. Okay, so this is the second iteration of the counting sort. And after this 6 and 6.1 in the output array, we have our result where we have applied counting sort on this input array, but only on the second digit, that is the tens place digit. And then after step number 7 and 7.1, all the elements in the output array, that is this 802.002.024, will be transferred back to the original array. So that's the basic for loop. And again, if you still observe, this output is still not properly sorted, because we still have one last iteration where now the div value will become 100 and we will target the hundreds position. So let's first transfer all these values 802.002.024 back to the original array. And there you go, this is now our new array, that is the same input array, on which we will apply one more time the counting sort, but this time the div value is going to be 100. Okay, so I'm quickly going to go through these steps also so that we don't leave out anything. Again, let's create the output array. We've created the output array. Take the range is obviously going to be 10. Create the count array with this range and initialize all the values to 0. Okay, so this is the third and the last time when counting sort is applied, where the div is 100. So we've done step 1, 2, 3. Step 4 is incrementing the count by calculating this expression by targeting the hundreds position now. So now the hundreds position is targeted, that is this position. So we are going to use this same expression, and just this time the div value is going to be 100. So I'm going to evaluate it one time and then we'll update all the count values, because this is getting very repetitive. So starting from 0 to the size is 8. So we'll go from 0 to 7 because I less than size. So ARR of 0 over here is 802. So 802 divided by, what is div this time? 100. So we will get 8 obviously. So this bracket will give us 8. Then we have 8 mod 10, which will again give us 8. Because it's not divisible, we get the remainder. So in the count array at the 8th position, so in the count array at the 8th position is where we want to do the plus, where we want to do increment. So you can see this individual digit is mapped with this 8 index position in the count array, where we have to do the plus. So it will become 1. Similarly, 0 will be mapped over here, over here, over here, over here, and over here. So we have 1, 2, 3, 4 and 5 occurrences. So the count will become 5. For this element, that is at this place, we have 1. So this 1 will be mapped at 1 index position. So that count will become 1. And for the last element, again we have another 0. Okay, so we have 6 instances, 1, 2, 3, 4, 5 and 6 instances of 0. So that count will become 6. We have one instance of digit 1 in the hundreds place, and we have one instance of digit 8 in the hundreds place. So 6, 1, 1. So step number 4 and 4.1 done. Step number 5 and 5.1 is the cumulative addition. So 6 remains as it is. Then we do 6 plus 1 is 7. Then we have 0 plus 7 is 7. Again 0 plus 7, 7. Here we have 1 plus 7 is 8. 0 plus 8 is 8. So we've got our cumulative count in the same count array basically. So step number 5 and 5.1 done. And step number 6 is where we have to take one element from the input array in the reverse order, starting from 7 to 0. So we have to pick one element and put it in the output array in a particular position based on this expression. So let's quickly evaluate this expression. We have to take ARR of I, which is ARR of 7 for the first time, which is 090. So 090 has to be allocated in the output array at some place based on this expression. So 090 divided by div is 100. So obviously 090, that is 90 divided by 100 will give you 0. That is 90 divided by 100 will give you 0.9. And since it is an integer, in programmatic way, 0.9 will be truncated, so you are left with 0. So this whole thing mod 10 will also give you 0, right? Because 0 mod 10 will give you 0 only. So count of 0 minus 1. What is the count value at 0th position? It is 6. 6 minus 1 will give you 5. So 5 will be stored over here, and at the 5th index position is where you have to store 090. Okay, so count of 0 would be 6 minus 1, that would give you 5. So output of 5 is where you have to store this 090. Then we will move on to the next value in the input array. We will take this 0, we will go to the 0 index position in the count array, we will decrement it by 1, so it becomes 4. At the 4th index position is where we will store 075, so 075 will come over here. Then we will move on to next element in the input array, which is 170. We will take 1, we will go at the 1 index position in the count array, we will decrement it by 1, so this becomes 6, and at the 6th index position is where we will store 170. Then we will go to the next value, that is 4, that is index position 4 in the input array. We will take the first digit, and this first digit is basically evaluated by this expression only. That's what we did in the first example. I'm just quickly going through because now you should get a hang of it, or you can pause this video and calculate this expression for every element in the input array. But basically we are going to get this 0, come to the 0 index position in the count array, decrement it by 1, that becomes 3, and at the 3rd index position is where we store 066. Then we move over here, we get this 0 index position of 045. We come at the 0th index position in the count array, decrement it by 1, it becomes 2. So at this 2 index position is where we store 045. Moving one place back, we have 024, again coming at 0 index position in the count array, decrementing 2 to 1. At 1 index position is where we store 024. Moving forward in the input array, or moving backward in the input array, we get 002. Again we are getting the 0 index position, decrementing it by 1, it becomes 0. At 0 index position is where we store 002. And then coming at the last element, or the first element basically in the input array, we take 802. We take the first digit, we come at the 8th index position in the count array, the value here is 8. We decrement it by 1, so it becomes 7. And at the 7th index position is where we store 802. So after 6 and 6.1, this is the output that we get. And now if you observe, this output is properly sorted in correct ascending order. So lastly, after 6 and 6.5, in the 7 and 7.1, we take this output and transfer it to the original array. Okay, and this is where the last counting sort is called in the Radix sort, and that's where the Radix sort will also stop executing, because we've pretty much got our sorted array, and it only called counting sort 3 times because the maximum number, that is 802, had 3 digits. So this is how the entire Radix sort sorting algorithm works with the point of view of the pseudocode, and this is how the Radix sort calls counting sort multiple times on individual digits for numbers which have more than 1 digit. Okay, so I hope you've got the entire working of Radix sort and how it uses counting sort individually and internally with the help of diagram. We've pretty much dry run the entire code, and we've taken a diagrammatic representation to better understand how every step impacts the internal steps and internal values, which ultimately leads us to this sorted array. So yeah, that's it for this video, guys. If you like this video, if you've now understood correctly how internally things are working, please give this video a like. This took a lot of efforts. Definitely let me know in the comments how this video was. Do share it with your friends. And in the next video, we are going to pretty much implement this. So we are going to write a C++ program to implement this pseudocode and convert it into a C++ program. So thanks for watching. Stay tuned for the next video. See you in the next one. Peace.